Hello, my name is Rich Howard, owner of Architectural Builder Supply. In this video is to bring you a closer look at the GRI, their part number 180-12-W. This is a contact switch that would be used in a steel door application, steel door, steel frame, and the reason is because it's a pressure fit sort of design. Okay. This piece of equipment would be very typical to install in a steel door and steel frame where you want to have an understanding of the condition of the door, whether it's opened or closed. This is a 3/4 inch size, and there is a link below this video to a document called Product Brochure that will give us lots of information. Let's start with the dimensional properties, and I'll hold up what would probably be certainly the door portion. I would think that the leads would be the frame portion. The diameter of the body, they call it out at 0.74 inch. My caliper tells me 0.75, 0.751. An outside diameter of the face, .923 is the outside diameter. You'd be able to drill a 3/4 inch hole into your door and frame, and these little spring-loaded tangs are just going to hold that in the closed position, okay? Or in the secured position. Your material thickness will be the distance between the underside of the head, which is very thin. It's probably about 25 thousandths. 31 thousandths. So you'll be able to fit that onto your typical 18 and 16 gauge doors. I'm sure it would fit on something thicker as well. White, that's the W in the part number. They can certainly do this in a black finish, which would be typical. Recessed, looking at the information down below this video, we're looking at a white one-piece design. This is a closed loop. We'll talk about that in a moment. 3/4 inch diameter recessed mount. Self-locking, that means these are going to literally snap in place. They say that they've got 12 inch worth of 22 gauge wires. I would say that that'd be accurate as well, 12 inch. UL and UL 10C fire rated. Lifetime warranty. Switches and magnets available separately should you throw out a bunch of doors and didn't save these. Sure, you can buy those separately. Switches, longer leads, zip cord, jacketed cable is also available. Supervisory loops upon request, built-in end-of-line resistors and diodes upon request as well. Now, the standard gap that you're going to be working on is going to be listed at up to half inch. Forgive me, up to half inch on steel. Gaps will increase substantially for installations other than steel. The closed loop is the part number 180-12. An open loop would be a 185-12. Single pole, double throw, double pole, double throw options are available as well, depending on what you want to communicate, based on the condition of the door. On page 2, there's a column for the part number, and then the loop type, and then the electrical configuration. This is a closed loop type. A closed loop type is the same as saying normally open, except that the definition is different on its natural state. I have been taught when you take a piece of electrified hardware out of its box, that's its natural condition. That's what it is. It's either normally open or normally closed. When you influence it or apply power to it, you then switch it to the other state, and then on the loss of power, it defaults back to its normal state. A closed loop is defined as when it's influenced. So when the magnet is present and it's influenced, there's continuity. When the door opens, breaking the continuity, what do we have normally open? There's no continuity that can flow. So the column of loop type is when you are influencing it, what's going to happen. So the manufacturers told me that closed loop are far more common than open loop because as you wire up a series of doors in series, you're looking for a break in continuity in all of those doors. If you were running an open loop where you are, needing the door to open in order to influence it to become, to have the kind of continuity that you're looking for, you'd have to run double wire, double the amount, because you're then wiring everything in parallel. So a closed loop is equal to normally open. Normally open is the state when you take it out of the box. When it's a closed loop, you're thinking in the terms of, what do I want to have happen when this is running? It's closed loop. I want it to be running. This would be considered normally open in the absence of power. When I take this away, there's no continuity, there's no power. There's no continuity. There can be power, but nothing's happening. It's not flowing. The circuit is then open. So the way I think of it is a wall with doors on it, and if any of those doors are open, I can't run my hand down the face of that door because there's not continuity. The face of that wall as I walk by. But as soon as I close that door, now I have continuity. We all think of odd ways to force ourselves to remember something. That's how I've done that. So a standard installation is a closed loop, which happens to be normally open. In the absence of power, in the absence of a magnetic field, it would be normally open. When you bring the magnet, this is a reed switch, you now have continuity. Okay. Where would you use this? Lots of places. Hospitals, airports. Hospital doors, you want to know what they're doing. Are they open or closed? In an airport, all those doors on the jetway, doors leading out to the jetway, you need to be able to report back the condition of those doors. And I would think if you've got lots of doors in that area, you do want them normally open or a closed loop so that if any of them are opened, you are, being able to report that condition back is what you're doing. There is finally a link below this video to the manufacturer's page where you can pull up not only all of the GRI products that we sell, but also a link to the manufacturer's website, as well as a link to the full product catalog. Any questions on the GRI? This is their part number 180-12-W. Closed loop, normally open, recessed steel door 3/4 inch door contact, or any other GRI product, please feel free to reach out to us. And thank you.